The broadcast is now starting. All attendees are in listen-only mode.
Welcome, everyone. This is Terry Erzman. I'm the Chief Marketing Officer for Percona. Thanks for attending our webinar today. Before we get started, could you please raise your hand in the GoToWebinar control panel if you can hear me? Thanks. I see a lot of hands there. Very good. We'll get started. We will be recording today's webinar, and we'll send a link to everyone following the webinar once we have it posted online. If you have questions today, please enter those in the questions area in the GoToWebinar control panel, and we'll answer as many questions as we can at the end of the presentation. I would now like to introduce Baron Schwartz. Baron is the Chief Performance Architect for Percona. In today's webinar, he will discuss zero downtime schema changes. Baron?
Thank you, Terry. Hi, everyone. Thanks a lot for joining us. It's always a pleasure. I know there's a lot of Percona employees, customers, friends, people I've met at conferences, and people who I've never met. And at the end of the slides, I'll share my contact information. I always enjoy hearing from you. It's always a pleasure to have conversations over email. In fact, somebody sent me a question just before this webinar, and I will respond to that after the webinar. If you have questions at any time during this presentation, feel free to ask them. I have my eyes on the control panel, and if I can, I will go ahead and answer the question in the stream as we go. Otherwise, if it's something that I've left plenty of time at the end so we can get to all of your questions at the end. So this picture on the left is silly-looking guy, is me. And I'm really, really happy because on the right-hand side is the new edition of High Performance MySQL that I published, and that's why the silly-looking picture has such a big smile on it. The third edition of High Performance MySQL was published, a month and a half ago now, and it's been getting quite good reviews. So if you don't have this book at all, or if you have an older edition, I encourage you to get that. I'm biased, of course, because I'm the author, but from my point of view, it's easily the best version of this book ever, which many people have called one of the best books about MySQL, period. There's a lot of information in there. The information about this online schema change process, some of the information is covered in that book, but some of it was actually, this is new since the book was published a couple of months ago. So today you will be hearing about things that you can't learn by reading the book. These are a handful of the projects and software tools that I've created over the years, just to kind of let you know if you're familiar with ModKit or InnoTop or Percona Toolkit. Those are things that I'm heavily involved in. In some cases I created them, some cases I participate in them. And just for fun, on the bottom left I threw in JavaScript libraries because I have a history as a developer in various realms, and one of those, I used to be a web developer, so I actually created some JavaScript libraries that eventually found their way into other libraries. I don't maintain them anymore, but I thought that would be fun for those of you who think of me as a database guy. And of course I work for Percona. On the left-hand side, here's a list of all of the services and activities that we engage in, and this is all centered around the MySQL database. We do know a lot about many different things, and we have competence with lots of different types of databases. Personally, I know a lot about PostgreSQL and Microsoft SQL Server as well as MySQL, but Percona as a company is focused on MySQL and services and software for MySQL. So, of course, we're most famous for consulting. We also offer traditional support contracts and training, which can be on-site or in public venues. And the conferences, many of you probably know about our Percona Live series of conferences, and custom engineering and evaluation for the MySQL server itself. We do a lot of work with people who need a custom version of MySQL, and we also do a lot of work with many of these third-party solutions vendors. One of the most prominent, I would say, is Tokutech with their TokuDB storage engine for MySQL. So we help folks like that a lot. And then on the right-hand side is a sampling of the software that we've created ourselves. All of this is free and open source software, and you can download it all from percona.com/software. So we have our version of the MySQL server, which we've named Percona Server to avoid name clashes. And then there's Percona Extra Backup, which is a hot online InnoDB backup tool. And Percona Extra DB Cluster, which is something we recently released about a month ago. It's been generating a lot of excitement, and I'll actually mention that a couple of times as we go through. And Percona Toolkit, which contains the tool that I'll be focusing on today. And then there's a lot more, many other software projects. There's monitoring products and tools for playing back a workload against your database, and a bunch more other stuff that you can find, all free and open source at percona.com/software. So now that I've introduced myself and Percona, let's go ahead and jump right into doing zero downtime schema changes with MySQL. Now, I realized when somebody asked me a question on Twitter earlier today that perhaps the title of this talk was a little too broad. Maybe it should have been qualified a little bit more, zero downtime schema changes for MySQL with the pt-online-schema-change tool from Percona Toolkit. But that's kind of a long title. But I just don't want anybody to be misled into thinking that I'm going to cover the entire scope of how you could possibly do schema changes in MySQL without downtime. I will be focusing on one tool, although you'll see I'll cover a lot of other topics as well. And I'm especially going to cover information that I think is helpful to you in assessing whether this is the right approach or a good approach for you to use in your own servers. I'm by no means trying to present this as the only way. This tool is one way to accomplish schema changes without taking downtime in your application, but it's not the only way. And I want you to know about the alternatives so that you can assess those as well. I'll do a quick demonstration. You'll see that's very quick because there's not a whole lot to demonstrate. The tool is quite simple to use. It's complicated internally, so it can be simple externally. And I'll cover some of these other solutions and the benefits and drawbacks of them. And then I've got lots of links at the end. The slides will be online as a PDF, and so you can download those afterwards. You can also, as Terry mentioned, get the recording, and you can send a link to your friends, and all of your friends can watch the recording. And so all of our webinars are available as a recording online at percona.com/webinars. So let's dive right in and talk about how MySQL does an alter table. And this is really the root of the problem. If you get a large table, you know that an alter takes a long time to run, and it locks that table. And if that's an important table for your application, which large tables usually are, then it effectively locks your application. Maybe some other things can run, but usually everything is just going to get locked on waiting for that alter to complete. And alters can take a long time. It can be somewhat unpredictable. You can try something out in another environment and try and gauge how fast a particular table is going to alter. And there's some blog posts on mysqlperformanceblog.com about how you can estimate how long it's going to take a statement to complete. But the short version is that an alter on a large table can take a really long time and block your entire application. So the reason for that is because the first thing that MySQL does is lock the table. It locks the table and then makes a copy of it and copies all the rows into this new table and then swaps the two of them out and releases the lock when it's done. And there are potentially other ways that this could be done that wouldn't cause this locking. So this is nothing particularly wrong with relational databases or the relational model. This is just an implementation detail about how MySQL does alter table. So the problem that comes out of this, of course, is that you have to. The blocking to your application is the most obvious problem, but then what you do to work around that is the next problem. And in many cases, your application deployment has to be scheduled on a weekend, or you have to take some application downtime and put up a maintenance page on your website, or whatever it is that you have to go through. It generally you start to become a little bit accustomed to it after a while and stop thinking about how much better your business could be if you didn't have to wait for these alters to complete and you didn't have to schedule them on the weekend or at nighttime or something like that. You forget that if you were able to alter tables with no downtime, that you could release your software much more often and your development team could be much more productive and you could get those features to market sooner and make more money sooner. So there's a really high impact to having blocking alter table, which is why we decided to approach this problem. So we can avoid blocking by doing it at some time that doesn't matter as much. Now that doesn't actually solve the problem of blocking. It just moves it to a time when the impact is less severe. But the impact on your staff, for example, might be more severe. They're the problems I just mentioned. There's also the problem of scheduling overtime or asking employees to be awake early on a weekend morning, something like that. None of those are particularly fun things for people to do. An alternative to that is that you can do what I call a planned failover. Some people call this a switchover, where you have a high availability system and you take advantage of your high availability infrastructure to avoid blocking. And this is something that we mention in high performance MySQL and has become a reasonably widely used practice, I would say. What you do is you take your master database server and you do a failover after executing the schema change on the secondary, on the standby server. And then you repeat that schema change on what's now the secondary. And by doing this, you're always performing the schema change on a server that's not actively in production usage. So this kind of masks the problem. There are some schema changes that you can't do this way because the schema change might be incompatible with replication between your primary and your secondary system. You might actually break replication if you don't do this carefully. But in many cases, especially if with proper planning, this can be a reasonable way to do schema changes without causing application downtime. It still has all of the problems of interrupting your workflow, and in high availability infrastructure in many cases it kind of runs on a prayer. It's not always something that's extremely well tested, and so there's always a little bit of a risk. I mean, who doesn't feel nervous about performing a failover from their production system to their standby systems? Another way that you can do this is by using a system that supports it natively. And this is actually a capability that's built into Percona XtraDB Cluster, a new high availability clustering system. It does a rolling schema upgrade by taking one node out of the cluster at a time, performing the schema change, and then bringing that node back into the cluster. So again, this is sort of like hiding the problem by taking it, doing it on some resource that's offline and not going to cause application downtime. Or you can emulate what MySQL does itself. So this is what pt-online-schema-change does. Instead of letting MySQL create a copy of the table and alter that and copy the rows into it, we perform those steps manually. And I'll explain a little bit more about how that works in the future slides. And my wish for MySQL is that we could use row versioning, such that you could tell MySQL this table has a new version of the schema, and it would be able to read from old row versions, and every time it writes a new row, it would write it in the new row format. And this is a technique that is, there's nothing novel about this. This is implemented in several other database systems that I'm aware of, and it works quite well. But this is not necessarily an easy engineering challenge. So I'm hopeful that at some point in the future, we'll be able to actually get this kind of capability inside MySQL. And that will make all of this pretty much a moot point. We won't have to go through any sort of external tools to do schema changes. So pt-online schema changes process looks a lot like what I showed MySQL's process before. The difference is primarily that we can just strike out that lock the table step at the very beginning. We go ahead and make a copy of the table, and then we apply our alter command to the copy, and we copy all the rows into the new table. And here we have an additional challenge because we've struck that lock at the beginning. That means that the application can continue to read and write rows in the original table, and it's going to take us some time to copy all of the rows into the new table. So we have to track the changes to the original table and make sure that they show up in the new table as well. And there are several ways to do this. The way that we choose is to add triggers to the old table that update or insert corresponding rows in the new table. And this, in practice, works quite well. So I've added that additional step under copy all the rows into the new table. And then when we're done, we can swap the old and the new tables. And MySQL provides a couple of atomic ways to do that. By default, pt-online-schema-change is going to use the rename table, which can accept more than one rename command at a time. So we'll simply rename the existing table to something else, and in the same command, we'll rename the new table to the existing table. And then our new table is in the place of the existing table, and we can unlock. But actually, there's no unlock to be done because we haven't been holding any locks. So at the end of this process of copying the rows, we just swap these tables, and we're done. It's not quite that simple. That's the concept, but implementation of anything like this is a lot harder than the concept. As you'll know if you've tried to do something like this yourself, especially doing something that's generic and works in lots and lots of different circumstances, becomes very difficult because of those little edge cases that complicate everything. So before you do this, the thing I want to tell you that you really, really need to do is check your backups. I would personally, no matter how much I've tested this tool and no matter the fact that my team and I have built this tool ourselves, I still would not trust it without working backups, because what you're doing is creating a new table, copying what you hope is a faithful copy of all the rows into the new one. Who knows if there could be bugs during that process. I'm not trying to scare you here, but I'm just trying to make sure that you understand this is kind of serious. If something goes wrong in this process, you've thrown away the good copy of the data that you have. So you want to make sure that your backups are there so that if something goes wrong, you can still recover your data. And when I say check your backups, I mean not only check that you have backups, but check that they're restorable in a usable way. So here's some diagrams of how we do this. The tool does not just do a single insert select to copy all of those rows from the old table into the new. It does this in what we call chunks or nibbles, and that means a range of rows at a time, starting at the low end of the table, at the low end of the primary key, and working towards the upper end of the primary key. It captures ranges of rows and then executes insert select to copy from the old table into the new table. And we've got these triggers which are set up to copy every column that is common between the two tables. So if we've made an alter where we drop column A on the left and we add column E on the right, then there's going to be a set of triggers that are going to copy columns B, C, and D from the old table into the new table. This way, when somebody writes or inserts, updates, or deletes a row in the old table, a corresponding activity happens on the new table. And this kind of illustrates that as we continue to copy these rows from the old table into the new table, somebody might change a row that we've already copied, and that's shown as a red stripe here on the left, and the triggers will update that same row in the right-hand table, also shown with the red stripe. So I want to show you a little demonstration. I hope you can see my terminal. I've made the font pretty large, so it looks really, really large to me. I hope it doesn't look too large to you. First, I'll just show you, this is the standard Sequila database. So we have a series of tables in here, and I'll show you the structure of the actor table. Actually, I'll show you the film actor table. That's the one I was going to alter. So here's the structure of film actor. We've got 3 columns: actor ID, film ID, and last update. And then we've got a primary key, a secondary index, and we've got 2 foreign keys that reference the actor and film tables. So I'll go ahead and exit back out of the MySQL prompt here and then run my command, which is pt-online-schema-change. I'm going to give it the -- execute option. That tells it to go ahead and make this change happen. We wanted to put an explicit switch in there so that you have to explicitly tell it, yes, I want you to alter the table. After that, the -- alter option specifies that I want to add a column called new col. And then the final thing on this command line is a specification of how to connect to the database server. In this case, everything is defaults. Host name is localhost. and the user and password are encrypted in my .my.cnf file, and then I'm specifying the Sequila database and the film actor table to apply this alter command to, and watch what happens. So we're done, and we copied, if you can see here on the screen, 6,315 rows in the table. So we actually altered this table, and if I connect back to MySQL again and run this same command, now we see that there's a new column here called new col, and we've just done that in a non-blocking fashion. Now this is not perhaps the best demonstration for a large table, but a large table would require longer to do, and lab demonstrations are always tricky, so I'm happy that this demonstration has gone well. A real live demo with something like a benchmark writing to the table while we altered would be more prone to errors, and I don't like that to happen when I'm presenting and recording. So as you can see, let me just scroll up so you can look at the text on the screen a little bit again. There's a few lines here. The first thing that happens is it says I can't connect to some other server on port 12346. That's a different port than the one we tried to connect to, which was 12345. I'll explain later what's happening there, but the tool is automatically detecting replicas, and because I've run all of these instances on the same server and I've got them set up in a funny way, it's unable to detect the replicas. So it prints out informationally. I'm going to alter this table Sequila.filmActor. It creates the new table. It says I created that new table okay. That alters the new table and says that was okay. Creates the triggers against it, and now it starts to copy these rows. And you see that happens quite quickly here. If it takes a long time, it's going to start showing you progress messages. You'll get progress messages every 30 seconds by default that will tell you approximately how much time remains. And in practice, those progress messages tend to be quite accurate. And then finally, we swap the tables. It says that was okay. You can see sort of the routine here. We're going to say what we're going to do, and then we're going to say whether that was okay or not. And finally, we drop the old table and we drop the triggers, and everything is okay. So now we've successfully altered Sequila.filmActor. This is really all there is to it. There are some special cases that I'll go into in a moment. Let me switch back to my slides. A few common questions that people might have. The first is, how fast is it? And this is impossible to say for any given case. My rule of thumb from what I've observed is that it's about 4 times as slow to do insert select queries as it is to just let the alter run. So you might want to consider this when you're deciding whether or not to take this approach. The alter might take, well, it certainly will take longer than, I'm sorry, the online schema change certainly will take longer than a plain old alter, but you might want to know approximately how long that's going to take. The reason that it depends comes into some of the external checks that the tool does. It does a lot of smart things that I haven't mentioned yet, and I'll talk about those in a minute. So those all fall under what I call safety and sanity checks. The first set of checks is that this tool is replication aware. That means that it tries to detect, as we saw, and connect to all of the replicas of this server that you're performing the alter on. It's also aware of how much load is on the server, and it automatically adjusts its activity to account for the load that it observes on the server, and it tries to make itself the victim. It's quite resilient, but it tries to make sure that if something is going to be interrupted because of this process, the tool should be interrupted rather than the application being interrupted. So let's dig into those a little bit more. So I already said that it detects all of the replicas. There's a few different ways that it does that. By default, it's going to look in show process list, and it's going to look at show slave hosts. Show slave hosts is not usually configured to report anything. That's something that you have to explicitly configure in your MySQL servers, and most people don't do that because most people are running with defaults. But show slave hosts is a way that you can tell which replication slaves are connected to your server and potentially how to connect to them. Show process list, you can actually detect the presence of a replication slave in process list by looking at the kinds of commands that those processes are running. And this is what it does by default, and it tries to figure out which servers the replicas are connected from and which ports they might be listening on. It attempts to connect backwards to them. In many cases, this works quite well. In some cases, it doesn't. In some cases, it'll also connect to a server that you don't necessarily want it to. So there's a recursion method option that you can specify to control how the tool will detect and connect to replicas. And if you're familiar with PT table checksum, this is exactly the same code that's used here. There's an additional option where you can actually point it at a table which contains the specifications of exactly the servers that you want it to connect to. And if you do that, then it won't try to do any of this automatic detection. It will simply look in that table and connect only to the servers that you specify. So this is one way, by the way, that you can tell it not to try and connect to and monitor replicas at all. You can point it at a table that has no contents in it, and it will just get nothing out of it, and that'll be a no-op. So when I say it connects to replicas and monitors them, what does that mean? It means that, in particular, it monitors the delay on those replicas. This process of running an alter table can cause replication to become delayed. And this, by the way, is one of the reasons that you might want to choose this approach over a big single statement alter that's going to take a long time to replay on the replica and cause the replicas to be very delayed in replication while that happens. pt-online-schema-change runs a series of small, short-lived statements, and these will typically not cause replication to be delayed. But if replicas are not very powerful, or if they're already kind of running close to the limits of what they can perform, then it's possible that the replicas will fall behind. And the tool will detect that, and it will stop or slow down its operation accordingly. And this is not only to accommodate for the extra load that the tool places on the server, but what if you just happen to enter your peak period of traffic and the replicas normally get delayed anyway? So the tool doesn't really care why replication is delayed. It simply cares whether replication is delayed or not. And if any of the replicas that it detects are delayed, then it's just going to stop and wait until they catch up. And it's quite smart about the way that it does this. And in fact, it'll also try and give you some kind of a progress estimate for how long it thinks it's going to be before the replicas are caught back up and it continues to perform its work of copying those rows. It also performs some sanity checks, including checking for replication filters. If there are any replication filters, then the tool refuses to operate. You can override that, but the reason we made it this way was so that the database administrator would have to do a positive verification that, yes, this is not going to cause any problems for replication, because it's impossible to really do that in an automated way. There are so many edge cases and strange behaviors with replication filters that can cause breakage. And the last thing I want to happen is for one of you to download this tool and run the tool and it immediately breaks replication. If it's going to break replication, it's only because you have told it to. So if there are any replication filters on the master or on any of the replicas, it will stop and tell you to read the documentation for the relevant command line option that controls this behavior. It watches the load on the server as well. By default, it's going to watch a status variable called threads running. This is a fairly good indication of the amount of load on the server. And it has a default threshold in there past which it will stop and wait for the load to decrease again. It's possible that a server could be in kind of a delicate situation, and just the fact that you've created a new table and added triggers on the old table that point to the new table could add some load to the server itself. So to prevent the tool from creating some triggers and causing an absolute runaway load problem that's going to cause your server to become unresponsive or fail to serve any of your real application queries, we also have a max, in addition to the max load, we have a critical load where the tool will bail out. And this critical load, I think, is set at 50 by default, 50 threads running by default, where the tool will throw up its hands and say, wait, this is not going well at all, and I bail out. So those are there to prevent bad things from happening. In practice, I have not seen either of these two limits being hit, but I just wanted to, we brainstormed about every possible way that this could go wrong, and these were a couple of the things that we thought of that we could add protections in for. So I've actually spent a little bit of time talking about the second half of this slide. I forgot to mention the first half of this slide. These chunks of rows that the tool copies are not fixed size. They continually adjust as the tool progresses. It doesn't try and hit a particular chunk size. Rather, it tries to hit and maintain a particular amount of time that each chunk takes to execute. So as opposed to some of the older tools in Percona Toolkit where you had to spend a lot of time adjusting the chunk size option, here you should leave the chunk size option at its default, which is disabled, and instead adjust chunk time. Chunk time is half a second by default, which seems like a good sort of a baseline amount of time that's not too small so that the tool has to do a lot of extra work, but it's not so large that it's going to cause a lot of interference either. And the tool uses a fancy algorithm to monitor the recent speed of copying rows, and it will generally hit this chunk time very closely. And even if the load on the server changes or something happens such that the tool slows down, it will continue to achieve that chunk time very predictably. The other thing it does is it tries to make itself yield in case there are locks, conflicts between other updates. And this is, of course, a reality in any transactional system. Any application that uses a transactional database should be prepared for deadlocks to happen. They're just a fact of life. The reality we know is that a lot of applications are not really built to handle deadlocks very well. And so when a deadlock does happen, it's often very ungraceful at the application level. So what we've done is we've set the lock wait timeout to 1 second by default, and that can be set at the session level. So the tool will connect and set its own lock wait timeout to 1 second. This is the InnoDB lock wait timeout, by the way. And hopefully if there is a lock wait, the tool will be the victim of that lock wait instead of something else. Now, deadlocks can happen with or without lock waits. We don't want something timing out on a lock wait, but we also hope that deadlocks won't happen. Deadlocks are more likely to happen with larger chunks of rows copied. So if this is happening to you, and I have heard one report of deadlocks being fairly commonplace while the operation continues, what you might want to do is try and set the chunk time to something small. Like you could set it to 1/10 of a second or 5/100ths of a second or something like that. Or you could even set chunk size if you want. Set chunk size to be 1,000 rows. Now the smaller these chunks are, the longer it's going to take the tool to complete its work. So you have to weigh that and balance those factors because the longer that this process goes on, the more likely you are to encounter a deadlock as well. But in the general case, it doesn't seem to be a big problem. And in applications that are resilient to being the victims of deadlocks, it's not a problem at all. Now, the pt-online-schema-change itself is pretty resilient. It will retry several times. There's an option to control that. So if it does become the victim of a deadlock, it's nothing to worry about. It'll just retry. Foreign keys are perhaps the most complicated edge case that we have to deal with. Foreign keys are not implemented natively in the MySQL server. In fact, they're implemented in the InnoDB storage engine. So we have to do a little bit of juggling to make things work correctly, and there are a couple of different ways that things can go. Essentially, if we alter a table that is referred to by foreign keys on other tables, when we do this little lock and swap at the end, swap and drop at the end, we need to make sure that the foreign keys from those other tables continue to reference the new table, not the old table that we moved away and then dropped. And there's a couple of ways to do this. One of them is to go to the old table and actually alter its foreign keys. If the other tables are small, the tables that reference the table that we're altering, we can alter those foreign keys to point to the new table without any problem, and that can be a short operation. And the tool can do that by default. There's an automatic, there's a command line option to select which method you want to use, and the automatic command line option we'll look at the size of those tables and try and decide what's the best way to alter them. Should we use an alter table on them, or do we need to do our other technique, which is to actually move the tables aside? Instead of using our rename table command, we can do a little swap dance in place. But this, for a split second, will actually result in the clients trying to access the table finding that the table is gone. So your application might have to be ready to handle connecting and trying to query a table and finding that the table is gone. It should be for only a split second, but during that split second you will have some queries that will cause errors. So you can read the documentation. There's quite a bit of explanation about exactly how it works and what all of the consequences are, but this is something that you should be aware of. And if the tool detects that there are any foreign keys referencing the table that you're altering, it will stop and insist that you read the documentation and instruct it on which way it should proceed. This is not the only tool that can do this process of online schema change. The original tool is Shlomi Noach's Oak Online Alter Table tool. This is a couple of years old at this point, and that was the inspiration for Facebook to create one customized for their own environment called OSC, which is for Online Schema Change. And we created pt-online-schema-change third after the Shlomi's and Facebook's tool. And I've recently learned about the Large Hadron Migrator, which is a Ruby gem. I'm not sure what the timeline was of, I don't know whether we created third or fourth, or maybe the Large Hadron Migrator was the fourth project to implement this kind of technique. But in any case, it's clear that this is not original, an original concept. We've implemented and I think improved on a concept that is proven elsewhere. And I'll discuss the benefits and drawbacks of these a little bit as we go. So the biggest benefit, the biggest limitation of most of these tools is they make some assumptions about your database. And the primary one there is that you have an integer auto-incrementing primary key. This is true for a lot of applications, but it's not true for all applications. And we had a particular customer who asked us to build a tool that could work with primary keys that are not integers. And the reason that most of these tools require an integer primary key is that they use this integer to create ranges of rows to copy from one table into the other. We use a different technique. It's much, much more difficult to write the code for, but in concept it's actually quite simple. It simply selects a certain number of rows from the table, looks at the last of them and uses that as a boundary, and then it selects again the insert select from the first to the last row in that boundary, uses the last row as the beginning of the next one, and this is why we call it nibbling, because every time we process a chunk of rows, we use the last chunk as the beginning point of the next chunk. So this means that we can select chunks of rows of a fairly predictable size from basically any table with any kind of a usable primary key or unique or even a non-unique key. So we have a lot less requirements and assumptions on your database than the other tools that require you to have an integer primary key. I should mention there's also some problems with the integer primary key approach, which is actually part of the reason that we moved away from that. Not only is it not flexible enough, but you don't really get you don't get predictably sized chunks of rows. The chunks of rows can vary depending on how closely together, there might be some gaps in your rows, and then someplace else in your table the values might be packed tightly together, and you might end up getting a lot more rows than you think. And so the runtime of each chunk tends to be very unpredictable. And we have about 6 years of experience in dealing with that in Percona Toolkit, which is part of the reason that we moved away from that approach. None of the other tools works with foreign keys, and they don't do all of these auto-throttling and sanity checks that I mentioned, and none of them is replication-aware as far as I know. I'm not a complete expert in every single one of them, but in reviewing the source code and in trying to learn from the work that they had done, we didn't find where any of them had implemented any of these things. So in general, I would say the Percona Toolkit tool has fewer limitations and is more broadly applicable. However, the benefits of some of these alternative tools are that they're customized to work quite well in their domain. In particular, I want to mention the Large Hadron Migrator is a Ruby gem, so it can integrate well with your Ruby migration process. So that might actually be a better choice depending on how you do your deployments. And of course there are bugs, because all software has bugs. At the moment, we don't know of any serious bugs in the tool. There is a limitation that I realized after we released the most recent version, and that's undocumented, but we'll put that documentation into the new version. And that is that you can't use it to rename a column. Because if you rename a column, when it sets up the triggers, it's going to see that the old column is missing from the new table. And so the triggers are not going to copy the contents of the old column into the renamed column. It doesn't understand the difference between renaming a column versus dropping the old column and adding a new one. The current bug list is always a good place to check. If you look there right now, you'll see that there are a couple of, I think there's a couple of documentation bugs, and there's a couple of little implementation glitches, but nothing serious that puts your data in danger. There might be some bugs in specific MySQL versions that cause problems, and in all honesty, full disclosure here, somebody has emailed me to say that they found a problem with row-based replication, and switching to statement-based replication fixed the problem. This is quite unintuitive for me, and I was not able to get enough information from this person to even really be able to investigate the problem. I would not be surprised if it was a bug in MySQL, because those do exist, but at the same time, I would also not be surprised at all if it was perhaps a mistake or an error on the part of the user or something like that. The problem that was reported to me was that some of the rows in the old table were not copied to the new table, and yeah, again, I don't see how that's possible, especially with row-based replication, but I don't have any information to be able to reproduce that problem. So again, not to scare you, just to let you know that you ought to be making sure that your backups are sound and solid before you do this. And I would also mention that this is a tool that we saw that other people have implemented, and I haven't seen a similar bug report from anyone else in any of those other tools. So in general, I feel quite safe about saying that this is something you can use in production. Should you use it in production is a good question. I think if the alter is going to be short, there's safety in numbers. Lots and lots of people use alter table in MySQL. And although there may be bugs in MySQL, most of the ones that people run into most of the time have been fixed. And so using alter is probably safer for your data, frankly, all things considered, than using an external tool that does sort of emulates the process of alter. So this is something to think about. I mean, if you are cautious with your data, as you should be, then if the alter isn't going to be very large and isn't going to cause a lot of serious impact to your environment, then maybe it's okay to take a 20-second lock or a couple of minutes of lock in order to avoid the risks of using an external tool. I think that's a perfectly sound way to go. There's also a class of alter table operations that can be accomplished much more quickly in newer versions of InnoDB, what's known as the InnoDB plugin if you're using MySQL 5.1, or if you're using MySQL 5.5 or newer, the InnoDB plugin is the only version of InnoDB that's available. And if you're using MySQL 5.1, you really ought to check that you are using the plugin, because it doesn't happen by default. You have to actually choose it. But it is much better, has many more features, has much better performance, performs much better on large hardware especially. It's a much better choice than the old version of InnoDB that you'll get by default with MySQL 5.1. In MySQL 5.6, some of these operations are becoming even more online. In the InnoDB plugin or MySQL 5.5, you can create and drop indexes with only a read lock on the table rather than a write lock. So this means that clients can continue to select from the table while the alter is running. Any updates, deletes, or inserts are going to block, of course. So it's partially non-blocking, partially online. In MySQL 5.6, that's going to get a lot better, and some of these schema changes are going to become even more online. And this is marching towards what I hope will eventually be the obsolescence of tools like this. And the final consideration is whether or not the tool is just going to make this alter operation take too long. The tool will add some load to the server. We know that's inevitable. Typically, it doesn't add very much, and it certainly throttles itself to avoid adding more than is necessary. But if this goes on for a long, long, long time, or if the tool is just going to take days to alter the table, it might be better to do, a 1-hour alter in the middle of the night and just get it over with. And I had one report of somebody stopping use of the tool when the estimated time remaining was, I don't remember what it was, but it was something quite long, and it was quite realistic to say that we should just take some downtime and alter the table instead of waiting for the tool to finish. So thus concludes my slides explaining the tool. I've got a series of slides here with some resources, pointers to the documentation, source code, forums, and the mailing list. And here are links to some of the other implementations of this, Facebook, OpenArc, and the Large Hadron Migrator, in case you're interested in checking those out. There's a few other general resources that I'd point you to at webinar at Percona. One of those is the upcoming webinars. All of our webinars are free, just like this one, and you can always get recordings of them after the fact. Vadim is the next webinar, and I don't think we have one scheduled after Vadim at the moment. But that's a week from today, and he's going to be talking about how to get the most out of MySQL when you're running it on SSD drives. And we've got training. Currently got 6 upcoming public courses scheduled, and we can schedule on-site courses for your company where we come into your offices and train you. And conferences, I think, hopefully I met a bunch of you at our most recent conference, the Percona Live MySQL Conference and Expo, earlier in April, April 10th through 12th. We have a couple that are upcoming. One is October 1st and 2nd in New York City. We had a Percona Live conference in New York City last May, and that was very successful. And we're going to repeat also our highly successful London event in November or December. I don't think that we have dates finalized for that yet. And then we're doing Santa Clara again next year, and that's going to be April 22nd and 25th. And the dates that I have on this slide are final, so you can go ahead and mark those on your calendar. Those dates won't change. At this time, I'm ready to take anybody's questions. We've got 12 minutes remaining, and I'm happy to answer any questions that you have.
Okay, Baron. Just quickly here, before we get to the questions, Shlomi actually had a comment. He wrote that the limitation of integer I true is for Facebook's OSC only.
Okay, so Oak Online Alter Table can perform operations on. Okay, thank you, Shlomi.
Okay, so some of the questions. With pt-online-schema-change, assuming InnoDB, the temp table uses InnoDB table space, which cannot be reclaimed without InnoDB file per table equals yes. Is that right?
Yes, that's true. So the table is, the new version of the table is created by basically copying show create table from the old table, changing the table name, and then executing it again. So it's going to have all of the same options and structure as the table that you're altering. And if you're altering an InnoDB table, then it's going to result in a new InnoDB table. If you're not using InnoDB file per table, then this is going to get created in your InnoDB table space, and you're going to require some space. Any alter table operation does this, by the way. It requires space. You have to copy the rows from one place to another inside of the table space in case of InnoDB, or in the file system in the case of other storage engines. So every alter table operation requires at least as much free space on the disk as the table is large, at least, potentially more. So this is, it is true that this will create some temporary table space usage, and then that space will be empty after the old table is dropped, but the same thing happens with an alter in normal MySQL. So that's not something that's unique to this tool.
Okay, next question. Excuse me. Does pt-online-schema-change need to be updated for Perl 5.14.2? And if so, are we accepting patches, or is this already done in trunk but not released?
I'm not aware of any problems with pt-online-schema-change in any Perl version. We support CentOS 5 and Debian 5 and a bunch of older versions of operating systems that ship with Perl 5.8 by default. And we've tested on as well the newest versions of the Fedora operating system, desktop operating system, which typically has quite up-to-date versions of Perl. It's possible that there's something in newer versions of Perl that causes a problem, but I'm not aware of any. So it sounds like the person who asked the question might have found a bug that I'm not aware of yet. And if that's so, then on the Launchpad, please file a bug on Launchpad and either attach a bug or create a branch on Launchpad and link it to that bug report. That would be great.
Okay, very good. Next question. What happens to the indexes and constraints in the swap?
The indexes and constraints are maintained. The exact structure is copied. Now, if you do an alter that drops an index, of course, that index goes away or adds a new index. Of course, that change happens. The tricky thing, as I mentioned earlier, was when we have foreign keys. So if a foreign key references a table, then we have to make sure that all of the foreign keys in those other tables start to point to the new table after the swap. And that's where I sort of mentioned that the documentation goes into details about this, because the behavior of InnoDB and MySQL is a little bit subtle. By default, the constraints are going to follow the rename. So when we rename the existing table to an old table, the constraints on all of those child tables are going to point to what's now the old table. And we have to fix that somehow. So we have to either alter those child tables to make their constraints point to the new table, or we have to set foreign key checks equals 0 and then drop the old table and rename the new one into its place, in which case the foreign key constraints don't follow or get pointed to a ghost table that no longer exists. So you have to choose, neither of those is 100% ideal, but you have to choose which way you want to do it. Or you can say auto and let the tool choose, but it does handle that. And depending on which method you use, you'll get some of these artifacts. You might get an artifact where the table doesn't exist for a split second while we're doing the drop and move into place. Or your foreign key constraints and indexes might get renamed on the child tables, because that's something that we have to do if we alter them to make their references point to the new version of the table. So I'm not trying to confuse anybody, but it is a rather confusing topic, and I encourage you to read the documentation on that, because it explains everything pretty clearly, I think.
Okay, next question. What if the base table already has triggers defined?
I didn't mention that. It's a good point. It can't work with triggers on the base table, so that's one of the hard limitations that we have. And somebody asked me at the recent conference if it would be possible to tolerate before triggers, because the tool creates after triggers. It might theoretically be possible to work on a table that only has before triggers, but in thinking through that, I'm not convinced that we can always predict whether those before triggers might do something strange. And so I don't necessarily want to get into allowing the tool to work in a way that I'm not sure is going to work correctly. So at the moment, there is this limitation of no triggers must exist.
Okay. Next question is, when you say bailout, what does that mean? Does the tool clean up, i.e. remove table and triggers?
That question probably was in the context of what happens if the load on the server gets too large.
Yes.
And to be honest, I don't remember off the top of my head whether the tool cleans up or whether it leaves things around when it exits. I'd have to check. I think the documentation should mention that.
All right. Next question is, are there any special notes for using this in master-to-master replication?
No, it should work seamlessly in master-master replication. I hope that the person who asked the question is not writing to both servers in master and master replication, because that always causes a lot more problems. I have not seen nor thought about usage of this tool, but I can't think of anything off the top of my head that would cause a particular problem there either.
Okay. Next question. Is there a way to not drop the old table? Just rename it and keep it?
I believe there is. My memory is a little fuzzy on the documentation for that. Let me switch here and try and answer that. Grep drop. Yes, there is a no drop old table option.
Okay. Next question. Do multi-part primary keys work with the new version?
Yes, multi-part, you can use a primary key that has essentially any structure, any data type, any number of columns.
Okay, next question. Are there any extra considerations when using this tool with partition tables? Also, are there any considerations when using this with MyISAM tables?
There are no considerations when using it with MyISAM. The way that it works is storage engine agnostic. With partitions, I'm not aware of any constraints. Off the top of my head, I can imagine that there might be some opportunities for us if we were partition aware to optimize so that we work only on rows belonging to one partition at a time. That's not something that we've done, but I don't know of any problems from not doing that. I can just think of this as maybe, depending on the type of partitioning scheme, it might work better if we did that.
Okay. What is the current bottleneck for performance? We're taking advantage of fast index creation speed up, or has this already been being used?
We're not currently doing anything with fast index creation. I've thought about it, but the problem is that in current versions of MySQL, even the fast index creation actually locks the table with a read lock. So the goal here is to avoid not only write locks, but read locks as well. And in future version, as I mentioned, this fast index creation is rumored or supposed to avoid taking even a read lock. So in that case, I think it's quite a legitimate optimization to create the new table without any indexes or without any non-unique secondary indexes. Copy all of the data into it, perform the swap, and then add the indexes to the new table. But we're currently not doing that. With regards to what is the performance bottleneck, this tool doesn't really do any heavy lifting. It just does a lot of complicated thinking. So the operations here really happen inside of the server, and some of them are quite complicated, particularly dealing with multi-part keys. All of those kinds of things can be very, very intricate. So it does a lot of complicated things, but not a lot of performance critical things in the Perl code. In the server, most of the work is done by two things. One is the triggers, and the other is the insert select statements themselves. So those are definitely going to be the performance limitation.
Okay. Next question. Would it be acceptable to use this tool to migrate from MyISAM to InnoDB following an upgrade from MySQL 5.0 to Percona Server 5.5 and avoid having to run MySQL upgrade?
Yes, that should work fine. I meant to mention this actually, that you can use it to perform sort of no-op alters that will just cause a table rebuild, such as you can replace optimized table. And there's an example in the synopsis in the documentation that shows you how to do that. Basically, you say alter engine equals InnoDB, and that will alter the storage engine. If the table is already an InnoDB table, it'll get rebuilt and optimized. But optimized table is also it's not an online operation. It blocks the whole table. So this is a way that you can do online non-blocking optimized table if you want to do that.
Okay, next question. How does the pt-online-schema-change handle failures, such as the MySQL server going down?
It's not resilient to that failure, so it's not going to try and watch the server until it comes back and then reconnect. I didn't want to build any of those kinds of features into it. I have them in some other tools, But the danger here is that if something happens, I really want a database administrator to have eyes on the system and to figure out what happened and to determine whether the system is safe to continue operating on, or even whether the tool itself, potentially the extra load or potentially some corrupt data in the table space that you weren't aware of until the tool touched it, caused the server to crash. So, if the server crashes or restarts or something like that happens, then I don't want the tool to continue working. So the tool will fail.
Okay. Very good, everyone. So that brings us to the end of today's webinar. Thanks, Baron, for your presentation. There were some unanswered questions, unfortunately, but I believe people can reach out to Baron directly if they have some further input. And as Baron mentioned, our next webinar is next Wednesday. That will focus on use of MySQL with SSD. Baron, would you like to wrap it up?
I'm looking. Unfortunately, I didn't see these questions while I was talking. So I'll just try and answer these in a blog post shortly after this, and I'll post a link to the recording and the slides when that's available too. So thank you everyone for attending. Great questions. Glad to have them, and I hope that the tool helps you. And please contact me if you have any questions or if I can be helpful.
Very good. Thank you, everyone. Have a good day.